Derek Britten.
And I'm Reynolds.
Over the past few years, producers have been mandated to focus on costs. Now we're seeing a shift in the industry with greater concern towards long-term productivity on a well and field basis. In today's Tech Talk, we're going to discuss ways to target and increase long-term production in the Willesden Green Cardium. This will be one of the fields and plays that we'll be focusing on with our performance reviews in the upcoming months. Murray, from a recent performance review, you've shown from the public data how an N2 foam can increase your well's productivity by more than $1 million in the first year. Do you want to start us off with a third-party study from the University of Texas, Austin?
Sure. Third-party study focused on the Willesden Green Cardium. And there was a total of 55 wells, 4 different frac types or frac fluid types, from nitrified slick water to N2 foam to nitrified cross-linked gel and to gelled oil. And on this slide we look at the 24-month performance based on cumulative oil production in a type curve type analysis, and we see that the N2 foam outperforms all of the other systems by a significantly wide margin here.
In 2015, you completed SPE paper 171583, looking further at the Willesden Green in the Cardium. Today, you've taken that one step further and you've used the updated public data to review these wells.
So if we look at this same area used in the UT Austin study, there's a total of 162 wells. And we're looking at 12-month cum production by frac fluid system on a probability chart here. And we see that the N2 foam wells outperform the energized slick water by upwards of 86%. So a wide margin on a 12-month BOE basis. Okay, and similar to what UT Austin did as far as a 24-month type curve analysis, this slide shows the difference between N2 foam and energized slick water over time. And if we focus on the last 6 months or so on this chart, we see the lines are actually diverging, meaning energized slick water is performing less well compared to N2 foam as time advances. And I'm attributing this to better hydraulic fractures created by the N2 foam.
So your fracs throughout your horizontal in the foam have had better cleanup, less water to imbibe into the formation, and overall higher conductivity from the near wellbore to the leading edge to the tip of your fracture, all contributing to this better production and increased production over time.
That's correct, yeah.
From an economic standpoint, how does this break down?
Okay, so we've taken a typical Cardium well with 25 stages, 25 tons of proppant per stage, looked at the baseline energized slick water cost. We've added a 30% uptick on that for an N2 foam cost based on higher cost of the nitrogen, for a total additional cost of roughly $375,000 per well for the N2 foam. And we look at the performance of the well over time, and we see that we have a simple payout based on the additional productivity of the well of roughly 3 months. And if we look at the first year incremental production at a $40 per BOE netback, we get an incremental $1.2 million.
And that's in the first year. As you get into the long term of 18 months, 2 years on, and you're getting that bigger differential in production, that netback's going to continue to increase.
Yeah, that's right.
Any further notes towards how the N2 foam can help contribute to your field's economics?
Well, N2 foam is a much more efficient frac fluid than slick water or energized slick water, so there should be a reduction in screen outs in the field. And if you reduce your screen outs, you reduce coil tubing work, and we know that coil tubing work is expensive.
So the reduction of all those remedial tasks to bring your well online.
Right. And another thing that customers or clients are talking to us about is parent-child effects in the Cardium. As we infill more wells, people are noticing as much as a 30 to 40% reduction in child well production over time.
And sometimes the parent well.
And sometimes the parent well if you have a frac hit during a frac treatment on the child well. So this really is affecting economics, and We believe that these foam systems will improve productivity in a depleted reservoir simply by adding energy to the frac fluid.
So any final thoughts or conclusions towards your performance review?
The M2 foam wells showed significantly better performance, upwards of 90% improvement on a 12-month cumulative basis. And this shows similar results to the third-party analysis done by University of Texas at Austin. And the economics of the M2 foam look very superior when compared to energized slick water or other frac fluid systems in the Cardium.
Thank you for watching today's Tech Feed Talk, a performance review of the Willesden Green Cardium. I'm Derek Britten.
And I'm Murray Reynolds.
And look back for further performance reviews in other fields in place.
And if you have any questions on today's Tech Feed Talk, please contact us at the numbers on the screen.